Listen-only mode.
Hello everybody, this is Jeff Checchi with Corsair. Welcome to the Intel X79 and Intel Sandy Bridge E CPU webinar here. I'm just going to go through a presentation here for you first, going over the new Intel stuff and some of the Corsair products that are out there to kind of complement it. And we'll follow that by doing a little Q&A session. I've got Jake Crimmins from Corsair also on the line here, and he's had a little bit of experience overclocking with the new chipset and CPU, so hopefully we can answer any questions that you guys might have. It's kind of difficult to unmute everybody at the same time. We'll get a lot of people talking at the same time, so the best way that I've found to do it is just to, if you have a question, just hit the raise hand button in the GoToWebinar software, and then once we kind of get through the presentation, I'll kind of go down one by one and start taking some questions. So it's 2 o'clock, so let's go ahead and jump right in here. So the Intel Core I series CPUs have been out since 2008. The kind of top tier CPU for a while now has been the LGA 1366 Core i7, which supports triple channel memory configurations. Following the 1366, we had the 1156. This was more the kind of entry level and mid-range dual channel supported CPUs. Those were out for a little while, and they were replaced by a second generation version of them in early 2011. So it's been, quite a while for the 1366 to be at the top of the CPU ladder. Definitely was time to update that chip, and now the LGA 2011 will kind of take the crown as Intel's highest end CPUs. So the biggest difference with the new CPU over the previous Core I series CPUs is definitely that the new CPUs support quad channel, which we'll definitely talk about in a couple of slides here. So with Sandy Bridge E, LGA 2011 is the successor to 1366, so this will finally kick the 1366 off the top of the ladder here. One of the big changes here with the new CPUs is that Northbridge functionality has migrated into the CPU, so you'll notice, here's a picture of the socket here. It's a bigger socket than what we've seen with the older CPUs, and also a little bit different DIMM slot configuration, having it on both sides of the CPU instead of one, which is necessary since a lot of the boards will support 6 and even 8 DIMM slots. So with Northbridge functionality, you notice there's not a big heat sink here where you'd normally have your Northbridge cooler, and that's because it's all integrated right into the CPU, which is going to definitely increase performance. The X79 is the chipset, the enthusiast chipset that supports the new CPUs, so that's what we'll mainly be talking about here. And we're going to see a lot of more 6-core CPUs with LGA 2011 and possible 8-core in the future, although from what I've been reading, it's more likely that we'll see 8 cores first kind of transition into the kind of server market rather than the enthusiast, but chances are we will see some enthusiast 8-core CPUs in the future. So LGA 2011 got its name by the amount of pins that are on the underside of the CPU, or I should say in the socket. It's not 2011 because of the year it's released, just a coincidence there. And you can see the 3 SKUs from Intel that are initially going to be available here with, one thing to mention also is with the integrated memory controller in these chips, they actually support natively up to 1600 megahertz. So this is kind of a first with a native 1600 megahertz memory support. This, is going to definitely, from what we've seen early on here, the memory controllers in these CPUs are very strong, and we've seen great results with overclocking at much higher frequencies when it comes to the memory compared to some of the older CPUs. So initial speeds for the CPUs are ranging from about 3.2 gigahertz all the way up to 3.6 and up to 3.9 with Intel's Turbo Boost technology. Turbo Boost is a way for the CPU to increase its clock speed relative to the amount of work that it's doing. So when you need the extra power, it'll boost it up to 3.9 and give you that extra performance without having to keep it there and use up all your use more power and get more heat in the system. So kind of a good feature there. So with cooling, it's kind of a first from Intel that they're releasing some of their CPUs without any cooler at all. So there's, people are going to have to kind of make a decision on what they want to use to cool their CPUs. What's kind of interesting here is that Intel is releasing a kind of an all-in-one water cooler that looks very much like our older H50 and H70. So, they've got their cooler here. With Intel providing a cooler like this, it definitely makes our Corsair Hydro Series coolers a little bit more attractive, since they're kind of embracing the same technology that we've been supporting for the last about 3 years now. So here's our most similar cooler to Intel's. This is the H70 Core. They're very, very similar. There's a few exceptions or differences between the two. One of them is that the H70 Core comes with no fans. So the idea behind this was to, we know that a lot of people will buy our coolers and, not even use the fans. They may go for a super quiet fan or a super high speed fan and just, chuck the fans from one of our coolers. So, anybody who's looking to do that can get this H70 Core and then use, whichever fans that they like on there. Another difference is that Intel's cooler uses rubber hoses. We've actually got our own type of hose here, which is extremely low permeability, meaning that you're going to get much less water evaporation over time than with traditional rubber hoses. So a lot of people have wondered, why do we don't use kind of standard rubber hoses? And it's really because we want this the coolant inside it to last as long as possible, and the design that we use here, definitely allows that. Another difference here is that Intel's pump only supports a single fan, so our pump unit supports 2 fans for both push and pull, so you can install a fan on each side of the radiator, which is going to give you a lot better performance than just having a single fan on there. And then important to note that all of Corsair's coolers, Hydro Series coolers, are compatible with LGA 2011 sockets except for the H40. So the H40 is a newer model that's kind of the entry-level Hydro Series cooler. All the other coolers, H60, H70 Core, H80, and H100, are all going to be compatible with LGA 2011. So with early testing, we've actually seen reports of some people running 64 gigs of memory on one of their boards and getting memory speeds of 2,000 megahertz. So this is pretty impressive right off the bat. Traditionally, the more slots that you have populated in a motherboard, the lower your overclocking results are going to be. So to see 64 gigs running at 2,000 megahertz is definitely a first with this new chipset and CPU. Maximum supported memory on this chipset is 8 gigabyte per DIMM slot. So with the boards that do have 8 slots, you will be able to get up to 64 gigabytes of memory, which a lot of people may begin to see, or what we might see become more commonplace is having like RAM disks for hard drive caching, or to put your page file on and things like that to kind of speed up the rest of the system. So there are some ways to get some use out of all that memory. When it comes to memory configuration, definitely always check the motherboard manual. Every manufacturer kind of has a slightly different way or different recommendation when it comes to installing the memory. But traditionally, from what I've seen so far, you're going to always want to have an even amount of modules on each side of the CPU. So if you have a 4 DIMM slot motherboard, normally you want to fill 1 on each side first, and then go for the other ones here. So like I said, definitely check the motherboard manual to be sure, but in 99% of the time you're going to fill all the same color DIMM slots first, and it's going to be even amounts on both sides of the CPU. With an 8 DIMM board, it's pretty much the same. You're going to kind of add them evenly to both sides, and fill up one color DIMM slot before the other, and there it is, all filled up there. So. Now get into or actually we'll go here now. So here's a list of all the part numbers from Corsair, all of our quad channel kits that we've announced here. Lots of different parts to choose from. I'll kind of explain what all these numbers mean. We'll start at the top here with the CM-GTX8. This is a 4-module kit. All these are going to be 4-module kits to fully take advantage of that quad channel memory controller. This is going to be the GTX8 is going to be the fastest, highest performance set of memory that we have at this point. They're tested at 2400 megahertz at 10, 12, 10, 27. So I I think that's pretty much the fastest quad channel kit out there right now. We've got a lot of 32 gig kits to choose from, which are using 8 gig density modules, going from 1600 C10 all the way up to 1866 C9. And you see we have our Dominator Vengeance, actually I said Dominator GT, Vengeance, and Dominator availability of 32 gig kits. And then in the 4x4 module kits, 4 gigabyte modules, you've got some 16 gig kits here as well. Dominator GT, Dominator, Vengeance Low Profile, Vengeance Black, and then Vengeance Green. It's actually kind of like an army color green to match up with ASUS's new Sabertooth board. So we match the colors there with that. This is actually a low voltage part, this green one. So it's tested at 1.35 volts rather than the standard voltage of 1.5. So you've got those there, and then also a couple of 8 gig kits as well. So 4 by 2 gig modules on the bottom here with the Vengeance Red and the Vengeance Black. So important to note here that all of Corsair's X79 memory are quad channel kits, and they all support XMP profile version 1.3, which is the latest revision to the XMP spec. And a couple notes on that XMP. There's 2 ways that Intel qualifies XMP. You have XMP Ready and then XMP Certified. So the difference here is that with XMP Ready, some user intervention may be required when you go and enable the XMP. So all memory that was made before XMP version 1.3 is basically going to be qualified as XMP ready. In order to get XMP certified status, everything has to be retested, and we have to have our certification test results submitted to Intel. There's slightly different testing procedures, which isn't going to make too much of a difference on the end user side, but also, Intel will have all the XMP certified parts officially posted on their XMP website for reference. So we will have many of our kits, if not all of our quad channel kits, up on their website very soon. So I kind of already mentioned this, but by default, XMP 1.2 compliant DIMMs are only going to be qualified as XMP ready. So in some cases, if you have an older set of memory which supports XMP, you may have to go in and still tweak a couple settings in the BIOS in order to get everything running at its rated spec. So when it comes to overclocking, it's a little bit different than with the older Sandy Bridge CPUs, and different in a better way here. Sandy Bridge CPUs originally were kind of limited when it came to setting the base clock frequencies, and the reason was because the base clock affected the PCIe/DMI controller frequencies, and these frequencies did not like to go too high, so there was no way to kind of untie this frequency from the base clock with the older CPUs. With Sandy Bridge E, you can now run higher base clock frequencies thanks to the added CPU strap option in the BIOS. So you're able to increase your base clock and then use essentially what's a divider to get your PCIe/DMI controller frequencies down at the kind of pretty much stock level, because you're not going to, get too much, higher benchmark numbers by overclocking your PCIe or DMI frequency. So here's the available CPU straps and just kind of an example of where you would set your base clock and how it divides it down into a kind of a workable frequency for the PCI and DMI frequency. So this really, with this CPU strap option, you now have a lot more freedom to play around with CPU and memory overclocking. So here's just kind of an example here on how we were able to overclock one of these new CPUs, the 3960X in particular, on an ASUS Rampage 4 Extreme motherboard. We were able to get it up to 4.8 gigahertz. You're going to see some settings which are kind of familiar with the older CPUs and some new ones here. There's a couple more voltages available with the new CPUs and motherboards. We actually have a more kind of in-depth, detailed blog post that just went live today, which kind of discusses this exact overclock here and how we were able to accomplish it with a lot more kind of screenshots of the BIOS and that type of thing. So if you're interested in that, definitely check out our blog. I'll have a link to it on the final slide here. Memory settings that went along with these CPU settings, we used our CMGTX8 modules, and we're able to get them up to 2400 megahertz, so 2442 to be exact, at 10, 12, 10, 30 timings. And one thing that's interesting here is they actually have two DRAM voltage values in the BIOS, and one thing to make sure you do is to set them both to the same value. So here's the kind of the screenshot of the overclocking. See, we're at 4.8 gigahertz with the CPU and 2442 on our memory frequency. So there you have it there. Then I've got, and this is a great example of why the CPU strap option with Sandy Bridge E has changed overclocking for the better. You can get much higher memory frequencies and higher base clocks than with the previous generation of Sandy Bridge CPUs, so it's definitely nice to have that option. So I've got a couple more slides here just to kind of show you or introduce you guys to some of the boards out there, some of the X79 boards that are probably going to be some of the most popular out there. From ASUS, they're, I think, the only company that I'm aware of that has all their X79 boards packed full of 8 DIMM slots. So no matter which ASUS board you go for, you're going to get all 8 DIMM slots available to you. They're traditionally their entry-level and mid-range chipset boards. They're going to have a couple different versions. They'll have a deluxe, a pro, a premium, those types of boards. That'll all kind of vary in the amount of PCI slots and SATA ports and USB ports and things on the rear I/O panel. Their Sabertooth board now is kind of more designed towards server systems. One of the things that I saw with this that was kind of interesting is they have I think 12 temperature sensors throughout the board, and I believe your fans that are plugged into the headers on this board can actually be controlled via the temperature that the various sensors are detecting. So that's kind of a cool innovation from ASUS. Their high-end gaming and overclocking board is the Rampage 4 Extreme. This one has all the bells and whistles, kind of heavier duty heat sinks on the chipset, but also a lot of kind of built-in hardware switch overclocking options. So you can actually do a fair amount of overclocking without even having to get into the BIOS. So depending on what you're looking to do, you've got a couple options there from ASUS. Gigabyte is definitely supporting the new chipset as well. They've got mostly some 4-DIMM boards with one 8-DIMM option. Their entry kind of mid-range level here is the UD3. You get up to the UD5 for 8 slots, and then for their kind of overclock-centric board is the UD7. This one has kind of the same deal here, where you've got some onboard hardware overclocking utilities built right in. And then they've got their high-end gaming board, the G1 Assassin 2, which is a 4-DIMM slot board as well. So lots of options from Gigabyte. ASRock has some boards right at launch. They, I think, have the only 6-DIMM board that I've seen so far. Kind of a strange design, but the important thing to note here is that you can run in quad channel even with, as long as you have at least 4 modules installed. So if you have all 6 installed, you can still run them all in a quad channel configuration. So with ASRock, it kind of just depends how much memory you're looking to get. The difference between these boards, other than their number of DIMM slots, is just going to be kind of the PCI Express lanes available to you, and then also kind of the smaller things like the amount of SATA plugs or connectors, and the rear I/O panel options as well. ASRock does have a micro ATX version available, one of the few X79 micro ATX boards, at least at launch. MSI has another one, micro ATX here on the end. And they're pretty much kind of the same story. The main difference between these boards, other than the amount of DIMM slots, is just going to be the PCIe configuration, how many lanes you have, and then also the SATA ports and USB rear I/O connectivity. EVGA is definitely not late to the party either. They have the FTW. They do have an FTW classified as well, which I couldn't find a good picture of. But coming soon from them, they're going to have a SR3 board to replace their older SR2. Kind of interesting here. They've got dual CPU sockets for 2011. The only real board that I've seen that supports that, and also they've got 12 DIMM slots on there. So if you're looking for the biggest beast of X79 that you can find, and that's probably this SR3 board, at least at this point. So a couple of notes here. I'm Jeff C. at Corsair.com, so feel free to email me with any questions. You can hit our Corsair forums here at ramguy.com to kind of bring up anything with the community or our tech support guys. If you need support for anything that any of Corsair's products, here's how to get in touch with us, and then here's a link to our blog section on our website, which the latest blog post is the X79 overclocking blog post. So you should get kind of more detailed information about overclocking within there. But that pretty much brings us to a close here. So if anybody has any questions, I'll be happy to answer them. There should be on the GoToWebinar software a little raise hand icon button, and I can